Hi everybody, today we're looking at Unit 1, Lesson 1, and this is all about graphing quadratic functions. So before we get into actually doing that graphing, I want to do a little bit of Algebra 2 review. And, of course, we're going to be talking about quadratic, so I wanted to just do a little bit of practice going back to some of the things you may or may not remember. We've got different forms of a quadratic: standard form, vertex form, factored form, all right? And then another skill that you'll need in this lesson is completing the square. So we're going to go over some of those things before we get into the actual main part of the lesson. So it says convert the quadratic from standard form to vertex form by completing the square method. All right, now when you complete the square, you're going to do b over 2 squared. So the coefficient in front of the linear term, right, the term that has just x to the first, we're going to use that value of b to come up with how we're going to complete the square. So let's go through this. First of all, let's do b over 2 squared to see what value we're going to need. All right, so b over 2 squared is required for complete the square. So in this case, b is -2. And that's going to give us -1 squared, or 1. So that's the value we're going to need to complete the square. So let's see here. In order to complete the square, I'm going to leave a place. I'm going to do my -24, and then I'm going to leave another place. Now, we have determined that the completing the square value is +1. So I'm going to go ahead and write in +1. But I can't just add 1 to the equation, right? That doesn't, it's now a different equation. I have to balance it by subtracting 1. All right, so what do we have then? We have y equals, now this part can be rewritten as x minus 1 squared, and then -24 minus 1 gives me -25. So we've taken the equation y equals x squared minus 2x minus 24, and we've simply rewritten it as y equals x minus 1 squared minus 25, right? Because x minus 1 times x minus 1 is just this, x squared minus 2x plus 1. So we've just rewritten it, right? So it says convert it to vertex form using completing the square, and then find the vertex. Well, we've put it in vertex form now, and the vertex can be found by looking at, right, h and k. So in this case, here's our h and here's our k. So the vertex for this is 1, -25. Now it's 1 because the vertex form is x minus h squared plus k. This is supposed to be a minus here, so we're only looking at this value. So if you want to think of it this way, it's going to be the opposite of whatever is in that binomial squared. All right, let's do another one. So we're going to do b over 2 squared. B in this case is -6. So we're going to get -3 squared, so that's 9. We're going to do x squared minus 6x, leave a place, plus 2, leave a place. We'll add in the value we got for completing the square, which is +9. And then to balance that, we'll do -9. All right, now this part here is going to be rewritten as x minus 3 squared. Plus 2 minus 9 is -7. So we get y equals x minus 3 squared minus 7. That means our vertex, right, this is our h, this is our k. is going to be 3, -7. All right, let's do another one. B over 2 squared. B is 8. All right, we're going to do y equals x squared plus 8x, leave a place, plus 6, leave another place. Our complete the square value is 16. Balance that out by doing -16. This part is going to be, now this is our value inside before we squared it. This is going to be x plus 4 squared. So x squared plus 8x plus 16 is equivalent to x plus 4 squared. And then we have plus 6 minus 16, so that gives us -10. Our vertex is going to be the opposite of whatever is inside. So if it's a 4, it's going to be -4 and then -10. All right, hopefully that's a little bit of a reminder of how to complete the square to go from a standard form to a vertex form and find the vertex. And we'll do some more of this as we get into the lesson. Now, the next part says find the vertex of the quadratic in standard form by using the formula for the x coordinate of the vertex, and then substitute that x into the equation to solve for y. So here's another way to use standard form to find the vertex. You don't have to complete the square. In this case, you can just use the formula for the vertex, which is -b over 2a. So we're going to do that next. Okay, so we're going to get x equals -b over 2a. So that's going to be -2 over 2 times 1. So x is -1. And then to find the k part or the y part of the vertex, we're going to take that -1 value and put it into our equation. So our vertex is going to be -1, 4. Right? This is just another way of approaching that same idea where we need the vertex and our quadratic is in standard form. Okay, last one on this page, -b over 2a. So we have a -4 and value a, of course, right? That's the value in front of x squared. Substitute 2 into our equation. We get y equals 1, so our vertex in this equation is 2, 1. All right, so let's take a look at this lesson today. We have a lot here. I mean, a lot of this should look familiar, hopefully, but let's again just take a look at what we have. We've got standard form, factored form, vertex form. When we're looking at a quadratic and a is greater than 0, the parabola opens up and we have a minimum. When a is less than 0, the parabola opens down and we have a maximum. The axis of symmetry is a vertical line drawn through the vertex across which the parabola is symmetrical. So, this would be our axis of symmetry, or on this one, this would be our axis of symmetry. Right? Domain is the x that are the set of real numbers. Range is y for all y that are the set of real numbers. y is going to be greater than or equal to k in our vertex, or y is going to be less than or equal to k in our vertex. And as we go through these, we'll take a look at all of that. All right, so example 1, graph the function f of x equals x squared on the grid below. State the domain and range. When graphing quadratic functions, include the following. We want the equation of the function, the vertex and the intercepts, axis of symmetry, and any key points. All right, so let's just fill in the table. That should be easy. Let's do that first. Now we're going to go ahead and plot those points and sketch our graph. Okay, we're going to label our vertex. All right, our equation is f of x equals x squared. We're going to draw in our axis of symmetry. You may want to use like a highlighter on your notes or like a different colored pen just so this sort of stands out a little bit more. We'll make a note here. Axis of symmetry. All right, so we have the equation, we have the vertex, we have no intercepts other than the x and y intercepts are both 0, 0. Our axis of symmetry, and any key points clearly marked. Now, the next thing we're going to do here is talk about the domain and range. And kids always get like a little rattled whenever we talk about this. So try not to get yourself too worried about it. Remember, domain are all the valid x values. So if we look at the x-axis, what values are going to be included? Okay. This graph is going to go, on end this way and on end this way. So for this graph, it's pretty easy. The domain is going to include all real numbers. And we're going to use interval notation from negative infinity to positive infinity. That indicates all real numbers. Now we're going to look at the range. All right, so the range is going to be all the values of y that are going to be appearing with the graph, right? And the graph starts at y equals 0 and it goes to infinity. And it does include the value of y equals 0. So we're going to again use interval notation. We're going to include 0 and go to infinity, right? So just as a little review here off to the side, anytime you use parentheses, that does not include. We'll say not including. And brackets are including. Now, whenever you have positive or negative infinity, you're always going to use the parentheses, around it. Okay, let's keep going. We've talked a little bit already about vertex form of an equation and how it helps us. If it's in vertex form, why do we like it? Because we can look at it and we can know what the vertex is. All right, so a little bit of, review reminder information right here. It says sketch the following quadratic functions on the grids below, state the vertex, the equation of the axis of symmetry, which is just going to be x equals h, the h part of the vertex, and provide the domain and range. All right. So what's nice about letter A and letter B is that they're both in vertex form. So we can just look at it and we know what the vertex is. This is our, whatever this value is, the opposite is going to be h, and this is going to be our k. So our vertex in this case is going to be -2, -4. Right? Now our axis of symmetry is x equals h. Right? H in this case is -2. So x is equal to -2. All right, now if you're not really sure what the graph is going to look like, you would want to put this into your calculator and take a look and pick off some good values that are really going to help you accurately represent this graph, when you do a sketch. So let's do that next. So the first thing we're going to do is go to y equals, and we're going to enter in the function. And then we're going to do zoom 6 so that we can see our function. Okay. Now, we know that our vertex is at -2, 4, right around here. So what I like to do is I like to pick a point to the left and a point to the right, and I usually like to go the same distance left and right. So if my vertex and my axis of symmetry is happening at x equals -2, I'm going to go a couple to the left and a couple to the right. So I'm going to pick x is -4, and I'm going to pick x is 0. And if I put -4 into my equation, I get 0. If I put -2, obviously I get -4. That's my vertex. And if I put 0 in, I'm going to get 0. So go ahead and plot those. Sketch your graph. All right, so it says sketch the quadratic on the grid, state the vertex, the equation of axis of symmetry. Maybe we want to just note the axis of symmetry. It's always going to be a line. Right, and then the last thing we're being asked, now that we have a very nice graph, is to determine the domain and range. Domain are all the possible x values. Since all x values are going to be included here, we're going to note that the domain here is all real numbers. I always like to do the domain and range after I've drawn the graph. The range is all the possible y values, and the y values start right here at -4 and including -4 and go to positive infinity. So our range are going to be from -4 to positive infinity. All right, let's take a look at letter B. The vertex, right, we have the opposite of what's inside the parentheses for H. So 5, 1 is our vertex. We definitely know we're going to plot that point, 5, 1, just like we plotted over here, we did the vertex. Right here, we're going to include the vertex. The axis of symmetry is going to be x equals the h value. In this case, the h value is 5, so x equals 5. I'm going to pick a point, a distance of 2 away from 5, before 5, and after 5. So that means I'm going to pick 3 and 7. If I put 3 into that equation, I get -1. If I put 7 in there, I get -1. All right, let me go ahead and plot those. I'm going to draw the axis of symmetry just because it's fun. All right, and then we're going to state the domain and the range. All right, so it looks like all the x values will be included, again, because this is going to go on infinitely left and infinitely right, and we will have all x values. So that's all real numbers. And the range is going to start at y equals 1 and go down -infinity. So we always read from left to right. So in other words, we're going to go from -infinity all the way up to and including 1. Now we're taking a look at a quadratic function in factored form, right? So there are some important notes at the top, what is factored form, right? In this form, the only points evident are the x-intercepts. So we know what the x-intercepts are. If we know what the x-intercepts are, that might help us find the vertex. We can use this formula. I'll show you how to do that. The y value of the vertex can be calculated by finding the value of, again, taking the x part of the vertex, the h, and putting it into the function. All right, and the a value determines whether the function is going to be opening up or down. So let's look at all those different things. So first of all, we want to note what the intercepts are. Well, if we set, x minus 3 equal to 0, x minus 7 equal to 0, we're going to get an intercept of 3, 0, and an intercept here of 7, 0. That was easy. If we want to know the vertex, we can just average the intercepts of the x-intercepts. So the vertex, the h part, 3 plus 7, that gives us 10 divided by 2, that gives us 5. And then to get the y part of the vertex, we're going to put 5 into our function. When we do that, we get negative 8. Right, so our vertex is going to be 5, negative 8. Our axis of symmetry is going to be the h part of the vertex. Axis of symmetry always starts with x equals, so x equals 5. Now we have 3 points, so we really don't need to make a table here. So we're going to go ahead and plot those points and sketch our graph. Right, our domain in this case is going to be all real numbers. And our range in this case is going to starts right here, right? That's negative 8, and it goes to positive infinity. All right, I would say at this point, pause the video and try B, and then come back and see if you got it right. Right, the x-intercepts here. So we've got x equals 0, and we've got x minus 4 equals 0, right? Before here we had x minus 7 equals 0, and we had x minus 3 equals 0. So our x-intercepts in this case are going to be 0, 0, and 4, 0. Our vertex, the h part of the vertex, is going to be found by averaging the intercept values for x. And then we'll take that value of 2 and we'll input it into our function to get the k value of our vertex. And that's going to give us 4/3. Right, so our vertex is 2 4/3. And our axis of symmetry, of course, is always x equals the h value. So x equals 2. And we'll go ahead and sketch that. Okay, now that we have the sketch, I think it's important to note that we did have a negative in front of the 1/3, and that does mean our a value is less than 0. So that means that our graph is going to be pointing down, and it is. It's a little confirmation that we did it right. Domain is going to be all real numbers. And the range is going to go from negative infinity up to and including 4/3. Right, standard form of a quadratic, right? One of the things to point out when we have a standard form setup, the C will tell us the y-intercept. So we're going to know that by looking at the C value, right? The vertex HK can be determined by completing the square, and the A value determines opening up or down. All right, so we did a little bit of practice with this when we were on the first page of our notes, so hopefully that helps you here. You may want to pause the video and see if you can complete the square for letter A. Letter B is a challenge problem. Put that in for a little extra fun today, all right? So at least try to do letter A on your own. All right, so I want to make a note to myself that I have a y-intercept at 0, 3, because c is equal to 3. And now I'm going to go ahead and complete the square. I'm going to leave a placeholder. I'll do my complete the square. Remember, completing the square is b over 2 squared. So that's going to give us negative 4 over 2 squared. That's going to give us negative 2 squared. So our complete the square number is 4. So we're going to add 4, and to balance it, we're going to subtract 4. Now we'll put it in vertex form. So this part here is going to be x minus 2, because remember, before we squared it, this number was minus 2. That's what's going to go inside the binomial. Plus 3 minus 4, that gives us minus 1. All right, that's where we're at. So our vertex is going to be 2, negative 1. All right, so let's put 2, negative 1. And I like to go a distance of 2 before and a distance of 2 after. So 2 before 2 is 0, 2 after 2 is 4. And we know that 0, 3 is our y-intercept. And if we put 4 into our function, we're going to get 3. All right, our axis of symmetry, just to add a note, that's going to be equal to x equals 2, the h part of our vertex. All right, we're pretty well set up here now. We can go ahead and sketch it. Once we have our graph, we can do our domain and range. Right, the domain is of course going to include everybody because these arrows are going to go infinitely left and right. So all real numbers. Our range is going to start at negative 1 and go to positive infinity. So starting and including negative 1 going to positive infinity. All right, we're all set there. Now, this next one's a little tricky because if we're going to complete the square, we need to remove that negative 3. We need to pull that out. Before I do that, I just want to note that we have a y-intercept at 0, negative 5. Right, so I'm going to go ahead and put that in my table. All right, so the next part is setting this up so we can complete the square. But what we have to do is we have to pull that negative 3 out. Right, so I haven't really changed anything yet. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is positive 12x. Now let me put in my placeholders to complete the square. My b value for completing the square is negative 4. And my complete the square value is 4. Now, let me just stop right there because what number did I really just add here? Negative 3 times positive 4 is positive 12. So I'm sorry, negative 12. So I just added negative 12 to my problem. I have to balance that by putting a plus 12 here. Okay? I'm going to rewrite x squared minus 4x plus 4 as x minus 2 squared, and minus 5 plus 12 is plus 7. All right, so now I have it in vertex form. My vertex is going to be 2, 7. And my axis of symmetry is going to be x equals 2. All right, phew, that one was pretty hard. We have 0, we have 2. I'm just going to add a value of 4 here. If I put 4 into my function, I get -5. All right, we need at least 3 values when we're drawing a parabola. All right, go ahead and sketch your graph. Our domain in this case is all real numbers. And our range looks like for the y values, we go up to 7, and then we have everything below 7. So from -infinity to 7. All right, there was a lot in this lesson. If you need to watch any of it over again, please feel free. Hope you guys have a great day, and thanks for watching.